Hi everyone, I'm Shaurya and I'm very excited to present S2AMP. It's a data set and a model which can predict mentors and mentees within the co-authorship network of a scholar. This work was done as a part of my internship at Allen AI in the Semantic Scholar team with Doug, Daniel, and Sergi. So why do we care about mentorship? Not all search engines, academic search engines out there like Google Scholar, Semantic Scholar, Microsoft, do not acknowledge mentorship. Uh, do, do we think citations, number of publications, and H index are enough to judge if the scholar is good enough? And so our eventual goal here is to understand the characteristics of a good academic and understanding the effect of mentorship on the mentees. So before we do that, we need a data set and a model. So here are some assumptions when we predict mentorship that we've made. That co-authorship is the only evidence of mentorship that we have, and unless a mentor-mentee pair publishes together, we can't detect it. We don't have any other proof of mentorship. Just to reiterate the problem statement clearly, we created a model and data set which captures scholarly mentorship. There's some related work by academic tree folks. This was a data set of mentorship in science with semantic and the demographic estimations. The size of the data set was 700,000 pairs, which they mapped to Microsoft Academic Graph. And with the demise of Microsoft Academic Graph, it will make it hard to keep updated, and no modeling was done in this work in spite of the motivation. So that's where we come in. We uh, get the true. So this is what we have done. So we crawl the web to get true mentor-mentee pairs, and then we train a model, and then we infer the whole thing on Semantic Scholar. So I'll talk about how we got this data set. We crawled 280,000 pairs from ProQuest, Math Genealogy, and HandleRed. And we were able, out of the 280,000, we were able to map 70,000 to Semantic Scholar using their co-authorship network. Academic Tree also provides 1.5 million pairs, but out of those, we were only able to map 260,000 to Semantic Scholar. So for these 300,000 pairs, we fetch their publication history and then we split them into train and test. Now, coming on to training the model, we did candidate mentor selection, feature extraction, and we had a two-stage model. So the actual mentor is among the selected candidate mentors. So what we do is we look at the co-authors of a scholar, and if they're senior, then we call them their mentors, and they're juniors, we call them their mentees. How we identify senior and juniority? Seniority is that their first publication date should be older than the first publication date of the mentee. And these are our negatives then, and the ground truth pair is our positive. And then we train the model, then we get area under the precision recall curve as 0.59. We throw it into a binary classifier. It's a light GBM model, nothing fancy. And we get 0.59 area under the precision recall. Then we realize we can do more. We can use these predictions to make a graph around the co-authors of the co-authors. So if my co-author has a lot of mentees, which will make sure that it's a signal that they are a mentor themselves. So they use that signal, and then we got improvement in our area and the precision recall curve to 0.70. And then we did error analysis. We manually labeled 100 samples where our predictions were wrong. And the good cases were that we were able to actually identify mentors. We searched for them on the web. The okay cases were very senior co-PIs were also predicted as mentors. Some people might find it okay, some people might not find it okay. And the failure cases were that the author name disambiguation has failed, and it might be an author matching error, or mentee is very prolific in some cases as well. So this is clearly an example of wrong match. And then finally, we inferred everything on Semantic Scholar. This is the final table, and this is included in the paper as well. So we have 24 million scholars in our data set, and the number of mentor-mentee pairs that we have is 137 million that we have. inferred using this data set. And we also provide the trained data and the code in our GitHub repo. If you can check that out. Thank you.